This is going to be the last one of our kind of like, I guess, like fundamental things happening behind the scenes lectures. This weekend, we're going to be doing both higher order functions as well as recursion. And the reason I distinguish those four subjects between what we've done so far is those four are kind of nifty ways to use things in JavaScript, whereas something like pass by reference versus pass by value, it just kind of happens behind the scenes, kind of like coercion, and it's really hard to avoid. So with the other things, you can avoid it if you really try. With this, there's no getting around it, so that's why we really want to spend some time talking about it and make sure people understand it. Um, Pass by reference versus pass by value is just a really fancy way of saying how do we copy things, right? How do we move things from one place to another? We've actually been doing this in every single lecture so far in terms of the workshops. By default, it's something that works if you just kind of assume it does. But if you squint a little bit and try to take a look at the details, things get pretty confusing very quickly, which is why I've also been trying to kind of shy away from talking about it as much in the lectures or in the workshops because they are designed to work more or less out of box for you. Okay, so let's talk about, before we move into that topic, we need to kind of take a step back and go back to our old friends, the primitive versus the complex values. Here we listed the primitives and the complexes. Just note that the big difference, once again, between the primitives and the complex is that primitive just means once I create a variable or once I create a value, I can never change it. I can only create another value, right? If I have a number, I can never change that number. I can only create another number and then override the previous number with this number. Same thing with numbers, strings, etc. Complex objects, on the other hand, or sorry, complex values, on the other hand, I am able to change, right? If I give you an array of 4 things, I want to add another thing to it. I now have an array of 5 things, right? And that does imply that I actually change the underlying array with 4 things. And what pass by reference versus pass by value basically says is the way we actually copy primitive values or the way we move primitive values is different than the way we move complex values because of the very fact that primitive values are things we cannot change, whereas complex values are things that we are able to change. So let's take a look at this in action. Here I have 2 variables, one's called British city and one's called American city, okay? On line 5, I basically say, hey, let's override the value of American city with the string new plus American city. Now, when I console log out British city, I get back, or rather, I get back York. When I print out American city, I get back New York, right? And so far, that more or less makes sense. Notice how on line 2, I define it as York. On line 3, I set American city equal to British city. And the American city part makes a lot of sense, right? Line 5 there pretty clearly says, hey, American city is now equal to new plus American city, which is actually British city, which is actually York. So therefore, I get New York. But the main thing here to note is that on line 3, even though I've established a relationship between American city to British city, notice how what I do to American city did not change British city. And as of right now, this makes kind of sense, right? Because if we say American city is going to equal British city on line 3 there, if I change American city, it really shouldn't have any impact on British city. So far, this kind of holds up with our idea of, well, yeah, if I set one value equal to another, of course I wouldn't change it if the thing that's doing the changing actually gets adjusted. So let's take a look what happens when we move into complex value territory, okay? On line 2 here, I have British city and it's equal to the array now, okay? It's an array with one element and that element is the string York. And American city is equal to British city. Now on line 5, I take American city, I unshift new, okay? Remember, unshift means take whatever is being passed in and we add it to the beginning of the array, okay? So in this case here, all we're really doing now is we're taking the array with the string York and we're adding new in front of it. So now it's an array with 2 elements, new and then York. But the interesting thing here that's different than what we saw before is, well, here if I take a look at British city, it also got changed, right? In the previous slide, when I did new plus York, well, the old York stayed the exact same. Here, when I do American city dot unshift new, it added it to both the American city array as well as the British city array. So for the next couple dozen slides, for the next dozen slides or so, we're basically going to be kind of drilling into this in more depth and trying to figure out why this is, right? Like, in what cases can we expect this behavior, and kind of what does it mean when we actually use variables in real life? Okay, great. All right. So fundamentally, and it's probably helpful here to take a look at the bottom right hand corner of your screen. We included some diagrams that hopefully makes life a little bit easier. Okay, so on the bottom right hand corner, right, when I create a variable like I do on line 4 there, the first, I set it equal to 20. The variable is called first, and it's pointing to a value called 20. On the value side, think of that value as representing a physical place in a computer's memory. Okay, like 20 is equal to a bunch of ones and zeros being physically stored in a computer's, let's say, hard drive somewhere, okay? And so what the variable first does is it points to that place in the computer's memory, and when it does, we'll say, oh, you want to represent a value of 20. Now, let's say on line 5, I now overwrite first with 30, okay? Well, the previous 20 value now no longer matters, and instead, we've now created a brand new value called 30 that has its own, let's say, address, or that occupies a certain amount of space on a computer's memory, right? And now the first variable points to that address. It points to that value. For the 20 that was just replaced, we don't need to worry about it too much. For now, we can just kind of assume that for every value without any variable pointing to it, the computer eventually cleans it up, right? The computer eventually erases it so that we can use that memory for other things. Just know that 20 kind of disappears into the void. We don't need to be concerned about it for now, okay? The most important thing here is between lines 4 and 5, just notice that all we're really doing is we're taking the variable first and we're shifting it and pointing it to another value. Now, really important thing to know on line 7, okay? We create another variable called second, and we set it equal to 30 as well. But notice how even though first and second are both variables with the value 30, they're not pointing to the same value of 30. Okay? When we have the assignment operator and we set it equal to 30, that basically says somewhere else in the computer's memory, we create another memory block and we give that also a value of 30, and we point the variable second to that particular place in the computer's memory. And why is that important? Because notice how first points to its version of 30 and second points to its version of 30. The two arrows never meet, right? They actually are pointing to their own distinct thing. And so therefore, if I change second, that's fine, right? Second changes, which is my intended effect, but first does not change. First stays the same. Okay, it's still pointed to 30. So this is a really quick primer on kind of how we do assignment operators for primitives. Now, what if, for example, I do, hey, first once again is equal to 20, but now we have this thing where we say, hey, let second equals to first. What happens then? Well, so whenever we do anything like what we see on line 2 there, where we assign one variable to equal the value of another variable, what that does is the computer is actually first going to check to see, okay, what's the underlying value? Is it a primitive or is it a complex value? In this case, the underlying value of first is 20, which is a number, which is a primitive value. And so when the computer sees that, what it does is it actually says, well, because 20 is a primitive value, I know that that's never ever going to change, right? First, or rather, that value of 20 will always be 20. Someone else could potentially reassign it later on, but I know that as of right now, 20 is a primitive value. That value can never change. And so rather than having the second variable also reference to the same value of 20, second instead creates its own value of 20, right, on the bottom right corner of your screen there. And then the second variable points to its own version of 20. So once again, even though we started with first equals 20, we have the first line. When we set second equal to first, the computer says, what's first equal to? It's equal to a primitive value. let me make a copy of that value and point the second variable to that. Okay, so now once again, the first and second variables are each pointing to their own version of 20, and we go back to what we saw last slide, right? If I change one version, or sorry, if I change the value of second, if I say, hey, why don't you replace yourself with a new value? That's totally fine, right? Second now points to a value of 21, but first does not change. Okay, and so this is a pass by copy. When we say pass by copy or pass by reference, this is a pass by copy. This basically says for primitive values, whenever we kind of pass the value, whenever we make a copy of the value, what we do is we're actually making another distinct copy of that value and then pointing the new variable to that. So the two variables never ever point to the same value. And in fact, that's a pretty hard and fast rule in JavaScript, which is that for primitive values, you can never have more than one variable point to a given value at a given time. Okay, so if I have this, if I say first is equal to 20 on line one there, no other variable will ever point to 20, or at least that version of 20. They can create their own version of 20 and point to it. We don't care, right? But no one will ever point to that version's value of 20 ever again. So far so good. Right, this just basically says on the crux there is just line 2. Whenever we're copying or passing a value that's a primitive, we always make a copy of it first and then pass the copy. We never give someone the original. We never give the original one. We never point it directly to the original value. Okay, we always point it to a copy of the value.
So this is passed by value?
This is passed by, this is passed by value. Yeah, I misspoke earlier when I said passed by copy. This is passed by value because we're actually making a copy of the value. Okay, so this is primitives. Oh, sorry, some more console logs here. Okay, and now let's move on to complex. Complex values are, well, I guess I don't want to say a bit more complex here, but if we take a look at line 7 there, let the variable first equal to the array 10, 20. That middle column reference, that's just the address I was talking about earlier. We just happen to kind of be a little bit more explicit with it visually. But if I have a variable and I'm pointing to a complex value, and then I do when I added that complex value, notice how you remember how like with primitives I always said, hey, if I add 1 to 20 and I want to replace the value with 21, I actually create a new value of 21 and I point the variable to that value of 21 and the 20 eventually gets removed, right? With complex values, it's the opposite. The array 10, 20 is still there, right? It's in the same position, and we denote that because we noticed that the reference address didn't change, right? All we're doing is adding an extra value to the array. So from the outside looking in, I should clarify this. As the array gets bigger, like it will take up more space in the computer's memory. Usually, when we say the address of a value, we just mean what is the address of the first element, right? Of the first thing in this value. And so in this case, even though we added more values to the array or to the whatever it's going to be, we didn't change kind of where we started, right? Like the beginning is still the same, right? And so therefore we can kind of add more data to the tail. But usually when we say address, all we're talking about is like the position of the very, very first thing. Okay, so here on line 8, when I do first.push 30, I have my original array. I don't change it. I don't change the address. All I do is add one more value to it, okay? And therefore when I console log it, I see, yep, first points to that address, which points to that value. And then next up, if I happen to have something like this, right, we have first equals this array and second equals this array. Even though it's complex, this goes back to to the analogy I've been using, for quite a few classes now. This is the analogy of, hey, me and my friend bought the same make and model of the same car, right? Even though we have, similar cars, they're not the same car, right? Like we don't share one vehicle, we have two distinct vehicles. This just means regardless of whether or not something is complex or primitive, if they're being defined separately, if they're being defined kind of, with a value, then in this case, even though they both have this complex value of the array 10, 20, if we look in the bottom right hand corner of our screen, notice how the variable first is pointing to one address that has that value, and the variable second is pointing to that address that has that value. And this just means, once again, these two are not related in any way. If I do something to one of the arrays, it will not affect the other one. Okay, this is just very plain simple. Like, I just happen to create two values that look the same, but they're not related in any way. Now, where we want to juxtapose this against, compared to what we talked about before with the primitive values, is this following slide here, where we still have our let first equals 10 comma 20, but now we say let 20 equal first. Okay, before I said what JavaScript does is it checks the value first, and it's a primitive, it'll make a copy. On the other hand, if it checks a value and it's a complex value, and remember, all values are either complex or primitive, right? So it's kind of a binary condition. In this case, all we're saying is if the value is complex, what JavaScript will do is it will actually point that variable to the same exact value as the one, or sorry, to the same exact value as the one you're looking at. So here, if I look in the bottom right corner of my screen, it's slightly inaccurate because actually the arrows should both be pointing to the same address, but hopefully you get the idea. Both the first variable and the second variable, they're both pointing to the same reference. They're both pointing to the same address, and therefore, if two things are pointing to the same address, they have to be pointing to the same value, right? It's like in the U.S., right? Like every address theoretically should only exist once, right? And so it doesn't matter if my friend in SF gave me address for somewhere in New York, and my friend in Boston gave me address for somewhere in New York. Those two have to be pointing to the same place, assuming the address is correct. And so same idea here. Both my variables first and second, they're both pointing to the same address. They're both pointing to the same reference, and therefore they must be pointing to the same value. And this just means, hey, if I change the value of second, well, what that does is it takes a variable, it follows the breadcrumb trail all the way to the value. It was 10 comma 20, and now I'm going to add 30 to it, right? But the problem now becomes, or not problem, but I guess the phenomenon now that happens is, guess what? First was also pointing to that address, which was pointing to that value of 10 comma 20. So when we changed 30 there, we also changed it for everyone else that was pointing to that same value too. And now when we console log out first and second, we see that they've both been changed. Okay, and so this is the pass by reference. When we say pass by reference, all we mean is whenever you're moving or copying a complex value, we actually pass the reference to that value. And the reference means we are actually passing the address of that particular instance or that version of the value. And so in that case, because we know that complex values can be changed, what JavaScript kind of assumes is, well, because complex values can be changed, I'm going to make sure that you are looking at that particular version of it, because that version can change, and if it does change, well, I want the changes to be reflected by you, or I want you to be aware of the changes, right? So same exact idea here. When we do a pass by reference, we are actually keeping the reference. We are keeping access to that particular instance of the value. Any questions so far? All right, great. We'll keep it moving here then. Yep. And so now we see how our friend Slice from way back in the Arrays 1 lecture on Monday? No, Sunday actually. Now we see why Slice is super important, right? Because when I do is when I do first slice, and let's say I want to copy the entire array. If you look on the bottom right hand corner of your screen, right? When I do this, right? When I do first dot or less second equals first dot slice, I am actually doing what happens organically whenever I try to copy a primitive value, right? But I'm doing it for a complex value. I'm actually just creating a new address, and at that address, I store a value that's identical to the original, but those two are completely separate, right? They're different variables pointing to different addresses that are pointing to things that happen to have the same value, but because they exist in different addresses, that just means there's no intertwinement between these two variables, and so therefore, whatever I change to one, if I change the second array here, guess what? It has no no bearing on the first array, because once again they were being stored separately and they were pointing to different addresses, and therefore they were pointing to different values. So this is why slice is kind of important, is because it basically allows us to create a copy that we can kind of play around with, change, modify, whatever, and it won't impact the original. Okay, so when we say passing values, what does that mean, right? So far, all I've done is show you well, let a equals b and let b equals c, right? So it feels a little bit kind of like, okay, is this kind of a illustrative example? But really, we've actually been passing values with every single function you've ever written, right? Because for the most part, every function you've written has always taken in an argument of some sort, right? Like every function basically says, hey, write a function that takes in an array or takes in an object or takes in a string and does this thing, right? Well, here, if I look at my function here, on line 1, I have my num and I set it equal to 10. On line 3, I have this function called adds20 that takes in a number. On line 4, we add 20 to that number, and on line 5, we return the number. Okay, so on line 8, I actually call adds20 and I pass in my num. So now on line 3, num becomes 10. Okay, when I execute adds20, num is originally 10. After I do line 4, num plus or equal 20, which means num equals num plus 20, so num is now 30. And on line 5, I return 30. Okay, so on line 8, the right hand side of my equal sign becomes 30, and so my return num has a value of 30. But the important thing here is to notice, hey, guess what? Even though I created a new number called 30, my num never changed. And why is that? It's because when I pass in my num on line 8 there, when I pass in my num into the adds20 function, that's an example of passing in a value. That's an example of kind of giving someone else a value. And when I do that, JavaScript looks at my code and actually says, okay, you're passing in my num. What is my num? Oh, my num is a primitive. Therefore, I'm not going to pass in your version of 10 into the function. I'm going to make a copy of your value. I'm going to make a copy of your 10 and then pass that value into adds20, and that's what num is. Num is equal to its own version of 10, and so whatever we do to num inside the function has zero bearing on my num outside of the function, right? And the only reason why that is because on line 8, once again, on the right hand side, when I pass in my num into adds20, I'm not passing in that version, that instance of the variable. I am passing in a copy of 10, right? I am giving the function its own copy of 10 to play around with, tweak, whatever it is, and my num is never affected. However, if I was looking at a more complex data type, so here it's the exact same idea as the previous slide, except now I pass in an array. On line 4, all I do is I add 20 into the array. I push 20 into the array, and then on line 5, I return the array. On line 8, I call pushes 20. I pass in my array, and then I do all this stuff. Now when I log out my array and my return array, in both cases, my array is the array 10, 20. And the reason for this one, in very parallel fashion to the previous slide, is because on line 8 there, right? On the right hand side of the equal sign, we see us passing my array into the function, except in this case, my array is not like when JavaScript takes a look at the underlying value of my array, it says, oh, it's a complex data type. I'm actually going to pass your version of my array into the function, right? So on line 3 and line 4, when we pass in my array and start changing it, that is the same version of the array that we created on line 1. And so whatever we do to that array inside the pushes20 function will also affect any other variable that's currently accessing that array, which includes the myArray variable on line 1. And so after we kind of put the array through the pushes20 function, well, when we return the value, we're returning a value of the array 10, 20, but that's like the same array as the one we created on line 1, right? That's the one we've been playing around with. And so therefore, both my array and return array have the same value because they're pointing to the same underlying address, and therefore they're both pointing to the same underlying value, which now has been changed to be 10, 20. Okay, any questions so far? Let me go back to the previous slide. does this make sense to folks? Does this slide and the previous slide make sense? Whenever we're passing in a primitive, it's always a copy. So we say pass by value, right? We're passing in the value. On the other hand, if it's a complex data type, then we're passing in the reference. We're actually passing in a reference to that particular instance of the value, as opposed to a copy of the value. And that's what we mean when we say pass by reference. Is it still good so far?
Yeah.
Great. Awesome. Okay, so now we can finally talk about something that's been kind of bothering us a bit for the past 2 days, right? What does triple equal sign mean when we actually compare it for complex data types, right? With primitives, it's pretty simple, right? Two strings are equal, same characters, same numbers, true equals true, etc. That all makes perfect sense. But we saw some kind of really janky outcomes when we tried doing this, right? When we did the compare objects problem, and also yesterday when we did a few other problems. So what triple equal signs in JavaScript means for complex data types, it means is it evaluates it and checks to see if these two things, it doesn't check to see if they have the same value. It checks to see if they have the same reference. Because if two things have the same reference, if two variables have the same reference, then they by definition have to have the same value, right? Like if two people live at the same address, then they by definition have to live at the same address, like at the same house, right? You can't. There's no two versions of the same address, okay? And so when triple equal signs, if I do something like this, array one and array two, well, even though those two arrays have the same values, they both live in different. They have different addresses, they have different references, right? They exist in different parts of the computer's memory, and I can easily prove it because if I change array 1, it doesn't impact array 2 or vice versa. And therefore, when we console log out array 1 triple equals array 2, we will get back false because they don't share the same reference, which means that if we change one variable, it will not change the other variable. On the other hand, if I have something like this now, array 1 equals that array and array 2 equals array 1, well, now when we do triple equals, we are going to get back true because at this point, JavaScript will say, well, array 2 and array 1 are pointing to the same reference. Therefore, any changes that happens to either array will always, any changes that happens to either array will be reflected by the other array because they're both pointing to the same address or to the same reference, and therefore they have to be pointing to the same value down the road. And so therefore array 1 equals array 2 is now true because they have the same reference. And the same thing applies for objects as well. We didn't show it here, but it's the same idea for objects. Okay. One last thing we'll talk about before we start on the workshop is this idea of shallow copy versus deep copy. Okay, so here on line 3, we go back to an array, but now we notice how it's a nested array, right? We have an array with only 2 elements. The first element is number 1. The second element is another array, and that array has 2 elements of its own. The numbers 2, 3. Okay. If I say array 2 equals array 1 dot slice, what that does is that copies array 1, but it will only copy it 1 level deep. Okay, and so you actually do a variation of this in one of your workshop problems tonight, so hopefully it becomes a little more clear then. What dot slice does is it goes through every element in the array. If the element is a number, it will make a copy of it and create a new array that stores that copy of that number, of that primitive. Okay, if the value is a primitive, then it will make a copy of that primitive value and store the copy of that primitive. However, if the value is a complex value, like here when we do array 1 dot slice, when the slice function goes through every element in array 1, the first element it encounters will be a number, and it'll say, great, I'll make a copy of it and put that in the new array. Everything's good so far. When it gets to array 2, it will say, oh, it's a complex value. Well, what I'm going to do then is I'm just going to pass the reference to that element. I'm not going to make a copy of it because it's a complex value. I'm just going to take the reference to that value and pass that into the new array. So when I console log out array 2, I get back, from the outside looking in, it looks identical. It looks like 1, 2, 3. But, or rather in this case, because it's a slice, the triple equals will never ever be true. But more importantly, So on this slide here, right, on line 1, we still have the same array as before. On line 7, we have the same array as before. On line 8, we make a copy of the array. Now, on line 10, we go back to our original array. We go to that second element at 2, comma 3, and we push 4 into it, okay? So now in array 1, that second element is 2, comma 3, comma 4. But if I take a look at on line 11, when I console log out the second element of array 2, it also changed. It also now becomes 2, comma 3, comma 4. And that's because what slice does is it goes through array 1, it only copies it one level deep, which means if it encounters a primitive, it'll make a copy. If it encounters a complex, it will only pass the reference. And therefore, because of the nesting, between line 7 and 8, even though we use slice, array 1 and array 2 are still tied together partially because they both share the same reference in their second element. And in fact, on line 13, which really drive the point home, if I compare the second element of array 1 to the second element of array 2 with triple equals, I get back true, which means, hey, they still share the same reference. Okay, so all of this is to say that even though slice makes a copy, just keeping in the back of your mind that there is that it's not foolproof. It doesn't mean any array you copy, it automatically always creates a brand new version. If there's other complex data types inside that array or that object, it will not create two distinct copies, right? Two separate copies. There might still be some overlap in the middle. And so what slice does is what we call a shallow copy, and then the opposite of that would be what we call a deep copy. We don't talk about how to do a deep copy nearly as much. I think one problem may touch on it, but for now we just kind of want you to be aware that there is a distinction between shallow and deep copies, and that slice is only a shallow copy. Okay, so that's pretty much it in terms of the material for this section. Are there any questions? It's a little bit mind trippy to think about. And when you do the workshops, like I know, like the more sometimes with these things, the more you think about it, the more confusing it gets. But like I said, right, anytime you pass any argument into a function, this is taking place. So regardless of whether or not you like it or even understand it, it's going to happen. JavaScript's going to use it a certain way, and so it's much better that you know what's going on than just kind of go off of what you hope is going to be happening. So, any questions? Anything I should kind of redo or cover again?
How would you check if two arrays have the same elements in
How would you check if two arrays are the same elements? You would do very similar to what we did in the compare object workshop. You would go through every single element in the array with probably a for loop.
All right, got it. Cool.
Or some variation of a for loop. Any other questions?
Right. Piggybacking off of that question, if you're going with a for loop through an entire array, technically, wouldn't that be going through the references and not? And when you're comparing them, wouldn't you be going through the references and not necessarily the actual values?
Yeah, yes. That's a really great question. Yeah. So sorry. The assumption I was making there was that the array only contains primitive values. If the array contained other nested arrays or other complex values, then what you need to do is you actually need to go into those arrays. And when we talk about recursion on Sunday, we'll talk about this, but it's essentially like a process where you need to keep going like kind of deeper and deeper and deeper until you're only looking at the primitive values. Because complex values at the end of the day are just kind of like they're containers almost for primitives, and for something, if you go deep enough, eventually everything boils down to a primitive.
Thank you.
Yep.
Is there a way to test if a value is primitive or complex, or like in the same way you can test if a value is true or false?
Yeah, just do a type of well, like was it like primitives are numbers, strings, booleans, undefined, nulls, and symbols. So if you do type of, the variable and you get back any of those 6 things, then you know it's a primitive value. Otherwise, it's a complex value. And complexes, I think, are just objects and functions. There might be one other one that I'm blanking on right now, because arrays are also considered objects when you do type of. But if all you're doing is checking for primitive versus complex, then it's fine to lump in arrays and objects in together.
Okay, thank you.
Yep. Cool. All right. Well, I will get the workshop started. Just sit tight for 1 minute here.